Okay, studying or this is analyzing proportional relationships. Let's start in with this to fill in the blanks. Ratios compare the relative size. Oh, you know what? Let's go red. Size or sizes of two quantities in a relationship. And really ratios are fractions. Okay, let's not forget that. If the ratio of two quantities in a relationship is always the same, the relationship is proportional. And remember, two equal fractions make a proportion. Complete the statement in the table to describe and identify constants of proportionality. When two quantities are proportional, they are related by a constant of proportionality, which, let's see, which is the constant value of their ratio. So here we have a few examples. The perimeter of a square is always 4 times the side length. So the constant of proportionality is 4. See, that's the constant ratio of of side length to the length of one side to the perimeter of the entire square. The perimeter of the entire square is 4 times the side of each of the side length. The diameter of a circle is twice the length of the radius. So that constant of proportionality, since it's twice, it's 2. And when we have 24 over 2, that constant of proportionality is really, simplify that fraction. It's a fancy term for just what's going on from one number to the next. And well, the first number is 12 times the size of the second. And in this last one, 4/8, the constant of proportionality is 1/2. Remember also, this is equal to 24 over 2, and this is equal to 4 over 8. Okay, so you're just simplifying those fractions. Okay, so complete the statement. When two quantities have different units, their constant of proportionality has the same value as the unit rate. So unit rate and constant of proportionality, okay, unit rate is the same as the constant of proportion ALITY. Okay. So as we see here, John finishes a 60-mile bike race in 4 hours. What's the unit rate? Well, if it's 60 miles in 4 hours, remember, you have to divide both by the denominator so you can get, let's see, I'm just trying to get fancy with my colors here. So it's what, 60 divided by 4 is 15 miles in 1 hour. Remember, unit rate has a 1 for a denominator, so you can just have 15 miles per hour. All right. It takes 3 hours for Amelie to bike 15 miles. So what we have is what is it? Is it 15 miles per 3 hours? And if you divide everything by 3, you would get that's equal to 5 miles in 1 hour, or 5 miles per hour. Okay, so you need to describe how to find the constant of proportionality from a table where the first 2 columns show values of related quantities. Okay, well, this is what you would do. You would choose any row. You would choose any row and divide the value in the second column by the value in the first column. So there it is. That's how you're going to find the constant proportionality from a table, okay, where the first two columns show different values. So there it is. And that's basically what's pretty much going on in the earlier stuff here. Although we didn't have two different columns, but we did have two different rates here. So fill in the blank. The equation for the constant proportionality K is K equals, let's see, y times y over x, sorry. Y over x. So your y value divided by your x value. Okay, that's how you get the constant of proportionality. Or as another way of getting it. So if we have our x values, 1 and 2 and 3 and 4, and our y, so the number of days you worked, like if you worked 1 day, you get paid $50. If you paid 2 days, it's $100. And you can probably guess that at this rate, you're getting paid $50 a day. Well, 50 is your constant of proportionality, okay? And you get it from your y value divided by the x value. So the y value is 50, and the x value is 1. So 50 divided by 1 is 50. And to continue this, it would be the y value, 100, over the x value, 2, and that's still 50. So you're getting paid $50 a day no matter what. 150 over 3, that's still $50 a day, and 200 over 4, that's still $50 a day. So here's the main idea, finding the constant proportionality from a graph. And use this graph to answer the questions. So let's see, complete the statement. So to find the constant proportionality, you divide, once again, you're going to take the y value of the coordinate pair and divide it by the, I gotta zoom in, just zoom in. You divide it by the x value. So remember, in an ordered pair, the first number is the x value, and the second one is the y value. So that's x and that's y. So you take your, once again, xy, xy. So you take your y, which is the 4, divided by the x, which is also 4, and that's 1. The constant proportionality is 1. The unit rate is 1. And here, this would also be 9 over 9, which is 1. It's unfortunate they did it that way. But and let's continue here. So let's find the constant proportionality from an equation. Complete the statements here. In any equation, the form y equals kx, x and y are, they are proportional. Oops. And the constant proportionality is k. Now, and you know what? By the way, I want to make sure that you know that you have y equals the constant times x, and also k. If you just want to know what k is, the constant proportionality, you take your y value divided by the x value. So I think that's a pretty important thing to know. The constant proportionality in the equation is y equals kx, so it's 25. And if this equation represents the cost of checking bags in for a flight, the constant proportionality is also the unit rate. Okay, another main idea here, complete the steps to show how to find the unit rate from a diagram among amounts at different times. Okay, well, what you would do is, well, we have this here. You have to identify the variables. Then you need to calculate the rate at each given time. And then finally, interpret the result. You know what? I didn't really type that all that well. Interpret the result. So let's see here. Complete the table. So we have, let's see, complete the table. To use this process, to find the unit rate for filling an aquarium. Okay, so here's the filling time, and that's how much was filled. Okay, so we find our unit rate in the filling time, how much for the aquarium. So it turns out it's 30 minutes for the aquarium. 10 divided by a third is 30. And for this next one here, it would be 15 divided by 1/2. Well, 15 is 15 over 1 divided by 1/2. That's 15 over 1 times 2 over 1, which is still 30 over 1, which is still 30, okay, which is the same as this. And then we have 5 divided by 1/6, which is 5 over 1 divided by 1/6, which is 5 over 1 times 6 over 1, which is 30 over 1, which is still 30. So it takes 30 minutes to fill the entire aquarium. And let's do this one too. So we get 72 when we take the 18 divided by a fourth is 72. Well, let's see, 48. I'm just going to go 48 divided by 2/3, which is 48 over 1 times 3 over 2, which is, I could cross cancel here. That's 1, and this is, what, 24? 24 times 3, I believe, is 72. So that's equal to 72 over 1. And then we have 36 divided by 1/2, which is 36 over 1 times 2 over 1, which is still 72 over 1. So Theo's resting looks like what? Resting heart rate is 72. Oops. Uh-oh. Oh boy. That was bad. Is 72 beats per minute. And then we have our final terms here. And I have for a constant proportionality, that is the constant. Oops. No. Did it again. Boom. Okay. So constant of proportionality, that is the constant. Oops. The constant rate. The variables. The constant that really. God, goodness gracious. Let me do that again. The constant that. It's the constant that relates the variables in a direct variation okay. Indirect variation. So just to let you know, direct variation would be y equals kx, and indirect variation would be y equals k over x. Okay, so this is direct, and this is indirect. Don't worry about the indirect. That's not going to happen. We're just talking about direct. So I just thought I'd explain that new word that popped up at the end of the lesson there. If, okay, so if y equals kx, then k is the constant. Okay. Of constant of proportionality. Okay. Next, we have what is a proportion? Well, I'm just going to say, first off, two equal fractions. But also, it's an equation. Well, yeah. I mean, come on. A ratio is a comparison that shows This is a comparison that shows the relative size of two quantities. And a unit rate is a rate with 1 for a for a denominator. Also the same as the constant of causative proportionality. So there you go. Those are the main ideas here for this lesson, and I'm hoping this was helpful for you. Thanks for watching.